Assalamu alaikum. Hello, everybody. Before we begin, let me introduce myself briefly. I am Benbouziz Oussama, and I am PhD student from University in Bawaqi, Department of Mechanical Engineering. Currently, I work in the combustion field. So today, it's my pleasure to share with you this work entitled "The Numeric Investigation of Structure and NOx Emission of Turbulent Biogas Single Division Flame in Counterflow Configuration." So for you, when we talk about energy in the world, the first thing that came to your mind, the wind energy, solar energy, and nuclear energy, because we hear about that every day on TV and social media. So I am sorry to say that all this energy are small players. The energy in the world is combustion, because the combustion of fossil fuels represents 84% of total energy consumption, where the renewable energy represents only 60%, which includes the nuclear, wind, solar, hydropower energy, etc. All this renewable energy represent only 60% of total consumption. So neither nuclear or renewable energies are at the present time capable to replacing 80% of energy supplied by fossil fuel. So the question here, what we can do? So there is several technologies to reducing the pollutant or global warming and improve the combustion process, of course by increasing the efficiency of combustion process or saving the consumption of fuel, like the flame stabilization, like the technology of flame stabilization, by using the bluff body or swirling technology, or using biofuels like biogas or syngas and hydrogen fuels, or use new technique in the combustion like the mild combustion or flameless. So here we have on the left side opposite configuration or counterflow configurations. Here we have the boundary conditions of the mixture biogas syngas used in this study. So we can say here on the right side the composition, the molar fraction of biogas, which include the CH4 and CO2, and the right side we have syngas, which include hydrogen and CO. We can say here in this table we fixed the composition of syngas by choosing the equimolar 25%, 25%. And the amount of methane in the biogas is varying from 0 to 50% to study the effect of adding the methane in the biogas. In the right side we have the composition of syngas, and you can see here also we fixing the molar fraction of biogas and varying the amount of hydrogen from 0 to 50%. Here we have the computational domain and the mesh in the 3D of opposite G configuration. So now we're going to the result. We have here the validation of our computational against the experimental data of Master X. We have here many more fractions along the central line for the experimental data of Master X against our computational. So the result here show a good agreement between our calculation and the result experimental data for the CH4 and 2 and oxygen and the water. So in figure 2 we can see we have the mini profile of temperature and NOx max fraction and central lines for the different mixture composition. So we have here the effect of composition. On the top we have the flame temperature. We can see here when we're adding the amount of methane or hydrogen in our mixture, the maximum flame temperature increase. So it's worth noting that the hydrogen is more sensitive, more than CH4 for this case. And here on the bottom we have the profile of NOx formations, and also we can see here when you're adding methane or hydrogen in our mixture, the NOx formation increase. And also here it's worth noting that the hydrogen is more sensitive than methane in our mixtures. In the right side we have a counter of flame temperature, And we can see here clearly when we increase the amount of methane or hydrogen, the hot region increase. So, now I'm going to conclusion. Three-dimensional numeric simulations is used to investigate the effect of mixtures and velocity injection on the flame structure and NOx emissions. It is found that the flame temperature increase with addition of hydrogen and biogas syngas mixture. The formation of NOx emissions can be suppressed by reducing the hydrogen and methane in biogas syngas mixture, and finally increasing the injection velocity to decrease the flame temperature and reducing NOx formation. Thank you for attention.